Hello, Math 2 students. It's time to review for the biggest quiz of the year. We're going to start out by subtracting. We're going to take 5x squared minus 4 and minus 6x squared minus 3x plus 15. Right now, what's going to happen is you're going to pause the video, you're going to do this problem, and then you're going to answer the question. All right, so here's what you need to do. You're going to make a column for all of your x squared terms, a column for all of your x terms, and a column for all of your constant terms. So I have a 5x squared. I have a negative 4. Now, I am combining this and the opposite of that. So this is negative 6x squared. That says negative 3, but because of this, we're combining this and the opposite of that. So I put positive 3x. And this says positive 15, but because of the negative, I'm combining this and the opposite of that. So I put negative 15 here. And now when I put my like terms together, I will have negative x squared plus 3x minus 19. And that is the difference of this second degree binomial and this second degree trinomial. On our next problem, we're going to multiply. And to start with, you guys are going to multiply this binomial times that binomial. So the video is going to pause. You're going to do the problem. You're going to put in your answer, and we're going to see what happens. So when you went to solve this problem, there's 3 different ways that you could have done it. You could use the distributive property, you could use a table, or you could use the FOIL method. I'm going to use the FOIL method. So I have 4 places where I'm going to put my 4 monomial terms, and this is where I put the product of the first, this is where I put the product of the outer, this is where I put the product of the inner, and this is where I put the product of the last. So when I look at my 2 binomials, this is the first term and that's the first term, and when I multiply them I get 2x squared. Now when I look at all 4 terms together, this term and this term, those are on the outside. So that's negative 14x. Now if those are on the outside, these are on the inside. That gives me negative 3x. And finally, this is the last term in this binomial, and this is the last term in that binomial, so that makes positive 21. And so this term and that term both have an x to the unwritten 1 power, so they're like terms. So my final answer is 2x squared minus 17x plus 21. All right, so now we're going to multiply again, but this time it's a binomial and a trinomial. And so the video is going to pause, you're going to do the problem, you're going to put in your answer, and we're going to see what happens. So, although there are different ways to do this problem, I believe the best way to do it is by using a table, because it's very important that you keep your answer organized as you're working your way through the problem. So, I'm going to make a 2 by 3 table. And I have x to the third plus 1 on the side with 2 rows, and x squared plus 2x minus 1 on the side with 3 columns. So x to the third times x to the second, I add the exponents and I get x to the fifth. X to the second times 1 is x to the second. X to the third times 2x is 2x to the fourth. 2x times 1 is 2x. X to the third times negative 1 is negative x to the third. And negative 1 and positive 1 come out to negative 1. So when I look at all of my terms, I have an x to the fifth, an x to the fourth, an x to the third, an x to the second, an x to the unwritten 1, and a constant number. So none of my terms can be combined together. So my answer will be x to the fifth plus 2x to the fourth plus, minus x to the third plus x squared plus 2x minus 1. The next problems are the binomial squared pattern and the sum and difference pattern. These are just patterns of multiplication that speed up the process of doing problems. Also, it makes it so factoring later on this week is much easier. So, on the binomial squared pattern, you know you're dealing with a binomial squared if you have a binomial and it's squared. So whenever you have a binomial squared, it's going to turn into this pattern. It's your first term and it's your last term, and they're both squared. But when it says the word binomial, one way that your brain can remember it is when it says binomial, you're always going to get a trinomial, something called a perfect square trinomial. So on our problem that we have right now on the board, our first is a 3x and our last is a -6. So if we take our first squared, that's 9x squared. Our last squared, -6 times -6, is +36. Then we multiply our first times our last, and that's -18x. And we multiply that times 2. So that's -36x. And that would be the answer of our binomial squared. Now, for a sum and difference pattern, you know that you're working with a sum and difference problem if it looks like the same binomial, but one of them is a sum and one of them is a difference. So we have x and 6 and x and 6. The only difference is one is a sum and one is a difference. On a sum and difference pattern, your answer will always be a binomial that's called the difference of two squares. So in our problem, our first is an x and our last is a 6. We know we're always going to have a negative in the middle on a sum and difference pattern. So we have our first squared is x squared and our last squared is 36. We have our minus sign in the middle. That would be the answer right there. Okay, so what's going to happen now is this problem, 2x plus 1 to the second power. You are going to stop the video. You are going to do the problem. You're going to answer the question that pops up on the screen, and we're going to see what happens. All right, this is the binomial squared pattern. So I take my first and square it. I take my last and square it. I take my first times my last, which is 2x times 2, and that makes 4x. And there's the answer. All right, so now we have 3x plus 2 and 3x minus 2. Do the problem, answer the question, let's see what happens. All right, so I have 3x and 2 and 3x and 2. One's a sum, one's a difference. So there's a pattern. The pattern is I take my first and I square it. I take my last and I square it. And there will always be a minus sign in between. And that is the answer. On both of these problems, we are going to solve a quadratic equation. We know that it's a quadratic equation because it has an x to the second power in both equations. Now, these equations look the same, but there is a big difference on how you might solve the problem. As you can see, we have two terms in our equation, and here they both have x's. In this problem, the only x is the x squared. The -7 is a constant and the 29 is a constant. So I will show you how to do both of these problems together so that you can see how that they're slightly different. So since both of these have x's, I want to get the x's on the same side of the equation. So I'm going to start out by putting it in standard form. So in standard form, one side of the equation is always going to be 0. So this side, 24x minus 24x is 0. On this side, somebody might want to add or subtract these, but they're not like terms because this is an x to the second and this is an x to the first. So I have 6x to the second minus 24x. Now I want to find the greatest common factor. So the greatest common factor between 6 and 24. This is 2 times 3. This is 2 times 12, which is 2 times 6, which is 2 times 3. So I have a 6x squared, and its prime factorization is 2 times 3 times x. And I have a 24x, which is negative, but I'm not going to worry about the negative this second. That's 2 times 2 times 2 times 3 times x. So there's my prime factorization of both of my terms. And I can see that they have a 2 in common, they have a 3 in common, and they have an x in common. So my greatest common factor is 2 times 3 times x. So my greatest common factor is 6x. So now I'm going to use the reverse distributive property to change this equation into factored form. So it's going to look like this. And my greatest common factor is 6x. So I'm going to put that there. And now I need to figure out 6x times some number that I don't know comes out to 6x squared. Well, if that's not obvious to you, that's fine, because right here, there's our leftover factor. It's an x. So we know that we're going to have an x here. And when we do the distributive property, that is 6x squared, which is what we want right here. So then, what do I multiply 6x by to get negative 24x squared? Well, the leftover factors are a 2 and a 2. So if I multiply that by negative 4 and do the distributive property, 6x times negative 4 is negative 24x, which is exactly what I want. So now, here's my equation, but my equation is in factored form. So here I have an x in front of the parentheses, so one of my solutions is x equals 0. And here I have an unwritten 1 for a coefficient, so I can just use the opposite. So my x is 4. All right, on this problem, remember the difference is these are both constant terms. So I'm going to go ahead and I'm going to put the 7 on the other side of the equation to get the x squared by itself. So now I have x squared equals 36. So most people can do this problem in their head. Some number multiplied by itself is 36, and they can figure that out. If you want to show your work on the algebra part of the problem, you would need to take the square root of both sides, and the square root of x squared is x, and the square root of 36 is either positive 6 or negative 6. So our answers are going to be 6 and negative 6. The reason that there are two answers is because 6 times 6 is 36, but also negative 6 times negative 6 is 36. All right, so now it's your turn. You're going to solve 3x squared equals 27x. The video will pause, ask you a question. On your mark, get set, go. All right, so both of these terms have x's in them. Neither one of them is a constant. So I'm going to put them in standard form by subtracting 27x on each side. On the right side of the equal sign, I'll get 0. On the left side, these are not like terms, so I just have 3x squared minus 27x. I'm not going to do the whole factor tree this time. I know that the biggest number that goes into 3 and 27 evenly is 3. And I can see that they both have at least one x. So when I go to write the problem using the reverse distributive property, I know that my greatest common factor is going to be 3, because it's the biggest number that goes into both of them evenly. And I'm going to have an x because they both have at least one x. So that's my greatest common factor. And then 3x times something gives me 3x squared. Well, this has got to be an x. And 3x times something gives me negative 27x. This has got to be a 9. And so now I just go to solve the problem. Since I have an x in front of the parentheses, I know one of my answers is x equals 0. And here, since my coefficient is an unwritten 1, I can just use the opposite, and my x is 9. All right, so here we go again. This is your turn. You're going to solve x squared plus 5 equals 54. Ready, go. All right, so on this problem, these are constants. And so instead of putting it into standard form where everything is on the left side with the 0 on the right, I'm just going to isolate the x squared part. So I'm going to subtract 5 and subtract 5, and I get x squared equals 49. And then I need to think of a number times itself that equals 49. And so I know that if I multiply 7 times 7, it's 49. And I know if I multiply -7 times -7, it's 49. So that is the answer to this question. And for our last problem, we have a guy kicking the ball up into the air. And that's what it would look like if you watched the video, just like the video that you watched previously where I kicked the ball into the air. The ball goes up, 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 comes down, 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 down. So it's at height 0 right here. It's at height 0 right here. And when we looked at the graph on the previous video, it was a graph of the height of the ball as time passed. So we figured out how long the ball was in the air. In this problem, the question wants to know how far did the ball travel? So from where it was kicked to where it landed, how far did the ball go? So instead of using a graph of height versus time, we're going to use a graph of height versus distance. And so this is what it would look like. The person kicks the ball. And if we want to know the distance the ball traveled, we need to measure from here to there. And that'll tell us the distance. So if this equation right here describes the flight of the ball, and this is our x-axis, and the flight of the ball looks like this, they want to know how far is it from this point to this point. So we know that this point right here has a height on the y-axis of 0. And we know that this point right here has a height on the y-axis of 0. What we need to know is where did the ball take off from and where did the ball land? This point right here, this is the x. How far is it from the origin where it was kicked, where it took off? And this is y. How high is it? Well, when it was kicked, its height was 0. Here, this is where the ball lands. So this is how far it is from the origin when it lands, and this is its height 0. So when it took off, its height is 0. When it lands, its height is 0. We want to know what's the difference in distance from where it took off to where it lands. So if we can solve this problem where y equals 0 because the height is 0, well, that problem right there is in factored form. We want to know what is x when y, which is the height, equals 0. Well, we can just use the zero product property. This has an unwritten 1 for its coefficient, so we just use the opposite. And this has an unwritten 1 for its coefficient, so we just use the opposite. So what we know is that on the graph, it took off 1 foot from where the origin is, and it landed 47 feet from where the origin is. So how far did the ball travel? Well, the distance that it traveled is 47 minus 1, or 46 feet.